Okay, so we're going to finish up today looking at 6.3, which is our last part of graphing sine and cosine. The first part is going to focus on graphing. The second part is going to be more about solving equations. So when we graph multiple transformations, there's a certain order that we want to make sure we follow. And we want to make sure we know what each number is doing in the problem. What's the shift, what's the stretch, all that stuff. So I'm going to do kind of a generic example with sine, but the same rules apply to cosine and actually any other trig function. All right, so we could have sine. So I've labeled these in the order that you would do them when you're kind of processing through them. So let's start with A. What kind of transformation would A be? That's your horizontal shift. And remember, positive shifts you to the left and negative right. Okay. B is still inside the parentheses, but now it's multiplication of the x. So what is B? Horizontal stretch. Is your horizontal stretch. And remember from yesterday, the bigger you make B, the smaller it gets, the more compressed it gets. What if B was a negative? Flips it over. Yep, horizontal flip would mean you're going to flip it over the y-axis. Okay, now we are outside the parentheses. What does multiplying by a number in front do? There's your vertical stretch. There's nothing backwards about that. The bigger you make the number, the bigger you make the stretch. What if C is negative? That's a vertical reflection, which means over the x-axis. And D, adding or subtracting outside the parentheses.
No, vertical stretch.
Shift. And for that one, positive would move you up, negative is down. All right, so when we have a problem that has more than one transformation in it, that's the order we always do them in. Horizontal shift, horizontal stretch or reflection, vertical stretch or reflection, then the vertical shift. So we might end up making more than one table. We'll make, the original, and then we'll make a table that deals with the first transformation, and then we'll take that table and use it to do the second one. So depending how many transformations we have, we may have to make 2 or 3 tables. Okay, I already pretty much gave you this order in more of a diagram format.
Are they gonna? Should we get those terms down? Like if they're like which of these numbers is a period change? We should know that that's a horizontal stretch.
Yes, I may use like the word phase shift. And if you said to me, like, I don't know what a phase shift is on the test, I wouldn't tell you. You need to know a phase shift is a horizontal shift. So any questions on the order or what? Sometimes some of them have a different name. So we'll take a look at a couple examples, maybe with 2 and 3 step transformations. So you're always going to start with your original table. Process the first transformation, then the second, then the third, and just keep making as many tables as you need to. Sometimes we can do 2 transformations in the same table. I don't mind doing that when there's only one vertical thing happening and one horizontal thing happening, because then they're separate. Like if you shift right and up, it doesn't technically matter if you shift right and up or up and right. It's the same thing. Where the order starts getting important is if you have 3 and 4 in the same problem. because it makes a difference if you, for example, like think of PEMDAS. If you add 5 to something and then double it, or double it and then add 5. Those are two different results. So you've got to be careful when you have multiplication and addition on the same axis. Okay? Same with 1 and 2. If you add multiplication and addition, then you have to follow the order.
Alright, so we need to make sure to multiply first and then.
Not for
Depends which one you're doing.
Okay.
For horizontal, no.
Yeah.
You need to add or subtract first, then multiply last. Okay, so looking at this one, do we have two transformations that are going to affect the same axis, or is each one doing something on a different axis?
Two different axes.
Yeah, this is a phase shift, and this is a vertical stretch. They're totally separate. So if we wanted, we could do both in the same table. The order technically doesn't matter.
Because we have both sides, we would just need to know the originals.
Yep, we're going to write down the originals first. Just to remind you what they are. So my originals for sine are x, y, 0, pi over 2, pi, 3 pi over 2, 2 pi, and 0, 1, 0, negative 1, 0. Going forward, I probably won't do the original. I just want to do it the first time. So there's my original. And if we follow our order, what transformation should we do first? We should process the plus pi over 2, and that's a phase shift. So a phase shift is going to affect which column? X's. And what are we going to do to all the original X's? We're going to subtract pi over 2. So let's deal with that first. Okay, so minus pi over 2 from all your X's. The first one will be negative pi over 2. And the second one? 0. Pi over 2. This one? Pi.
Oh, yeah.
And then 3 pi over 2.
And 3 pi over 2. Okay, any questions on subtracting pi over 2 from all of those? Okay, so that handles this. Now we need to do that. What's the 2?
You're multiplying the y value by that.
Right, we're going to multiply the y values by 2. That's a vertical stretch. So let's double all the y's. So 0, 2, 0, negative 2, 0. And that's the table that I would be writing. The final answer. I think I mentioned it a couple times, but the way it works, you're going to get 1 point for every x and y value. So that table would be worth 10 points on the test. Any question on the table? Okay, and now, let's see, our graph. Let me see if I can move that down. All right, so I would scale the y-axis by 2's. Remember that the axis always has to be 0. I don't know why, but I've seen some people try to change it to make the actual axis a value other than 0. You can't do that. Okay, and now we need to label the x values with numbers that are equally spaced, and these x values are evenly spaced. So I would just use those. So negative pi over 2, 0, pi over 2, pi, 3 pi over 2. And now we're just going to plot the points. 0, 2, 0, negative 2, 0. 0, 2, 0, negative 2, 0. And there's your sketch. Any questions on that? We've been doing multi-transformations all year, so I'm not expecting people to have a ton of trouble with this, but it is a different kind of picture. It's not one we're used to graphing. So. Any questions? Alright. Let's try this one. 3 cosine 2x plus 1. Well, we must have two transformations affecting the same axis because there's only 4 transformations and 3 of them are there. And there's 2 on each axis, so we do have to be a little bit careful about order this time. All right, let's put our originals just off to the side.
Which number are we doing first?
That's my question. Which number do we look at first? Yeah?
Period change.
We're going to do the period change first. Is that the only transformation affecting the x-axis? Yes. So we can do the period change and know we're done with the x column. Okay, how am I supposed to get my new... Divide these all by 2. So we're going to get 0, and then... Yep. Pi over 2. 3 pi over 4, and pi. Okay. So these are all pi over 4 apart. How much would that be in degrees? Pi over 4.
No.
Pi over 3. 45. So these are all spaced 45 degrees apart. Normally, they're all spaced how far apart? They're normally spaced 90, but you've compressed 90 by a factor of 2. That's why they're all 45. Okay. Now, what's the next transformation we do? The vertical stretch, and then vertical shift in that order. So we're going to take each y value and do what to it first? Multiply it by 3, and then add 1. That's the order. So 1 times 3 plus 1 gives me 4. Times 3 plus 1? 1. Times 3 plus 1? Negative 2. 1. And 4.
I thought for one of those you're supposed to do like the reverse. Or is that only for the x side of the parentheses?
That's only for a phase shift or horizontal shift.
We did vertical shift yesterday.
We did all the shifts on Monday. I'm pretty sure we did all the shifts Monday. We did all the stretches Tuesday.
What did we do yesterday? We did
No, Monday we were just cracking.
Oh, Monday Monday. We have to finish 6.2.
Yes.
Yeah, Monday we finished 6.2. Yep. Tuesday we did the stretches. Wednesday we did the shifts. Yeah. And Thursday we're doing what we're doing right now. Yeah. Okay. So let's graph those. Again, label your x-axis with the values in that column. Those are going to work fine. So 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. For y's, well, I need to go up to 4, and I need to go down to negative 2. So what I probably want to do here, it's not perfect, but add another one. So now I can go 0, 2, 4, negative 2, and that covers it. Okay, so 0, 4 is my first one. And then pi over 4, 1. So 1 would be right about there. Pi over 2, we're at negative 2. 3 pi over 4, back to 1, and then back to 4. Because I went by 2, some of my x values, or some of my y values, didn't land right on a line. That's okay. It's not, when you have to approximate halfway between 2, that's not bad. And there's your sketch. Any questions on?
Alright, so two of them, you always combine into one set, like you're not going to be making three tables.
Well, you can. I wasn't sure at first if that would be a good idea, if people would be able to do that all in their head. But it seems like people did okay with that. So,
Okay. We're going to be doing more examples.
yeah, I had one more. This was our last one, but this one didn't have two transformations on the same axis. It just had one on each. But it does do a phase shift, and we haven't done phase shift yet. So if you want to do it as two separate tables, this is how you do it. What transformation would we do first?
The minus
Okay, so let's make a table for just that problem. Okay, we're going to break this down into two tables. When you do a phase shift, what stays the same? The y's. Okay, we're going to take our original x's, and what are we going to do to all those numbers? Add pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. That's not the final answer. That's just the phase shift. Any questions on that table? Yeah?
Why can't you just go from that table and then add 5?
That's what I'm going to do right now.
Oh.
Yeah. I'm just breaking this one down into two tables on request. So now, to do the second table of x minus pi over 2 plus 5, well, we already handled the pi over 2, so now we just have to handle the plus 5. What does the plus 5 do?
Adds 5 to each y value.
Adds 5 to each y, so the x's are going to stay the same. So we're going to have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. Now let's add 5. What do I get for y values if I add 5?
6, 5, 4, 5.
Yep. And that's how you could do the problem, breaking it down into individual steps. Again, the only thing I'm going to look for on the test is the final answer. Okay, the final table. Okay, let's see. So we got to go up to 6. Looks like I already set this one up to go by ones. And for x's, just use your labels in your table. 0, pi over 2, pi, 3 pi over 2, 2 pi. Do I need one more? And plot your points. 5, 6, 5, 4, 5. 5, 6, 5, 4, 5. Am I one off? I think I'm one off. That's what happens when you do it too fast. 5, 6, 5, 4, 5. Am I okay now? 2 pi 4. Yep, that looks good. Okay, and there's your sketch. All right, so any questions on graphing multiple transformations? Okay. So what I want to do this time is I want to use the calculator to type that graph in. So I want to find a complete graph and then find the domain, range, amplitude, and the period. Okay. Let's start by typing that in. Okay, so we've got 4 sine 3x. We need to make a choice about whether we're going to do this in degrees or radians. Let's try it in radians. Let's go to radians. And let's do zoom 7. Okay, is that a good window?
Barely.
Just barely, yeah. I think it does get the maximum and the minimum in there. Because if you do zoom 7, that's what it's going to use for numbers. It's that -4 and 4 on the y min and max. It's a little closer than I would normally do it, but technically it's okay. All right, let's start with the domain. What is, bless you, the domain of that? All real numbers. There's no gaps, there's no holes, there's no asymptotes. It's a continuous function. You never lift your pencil to draw it. Okay, so that's all real numbers. Okay, they want range. Okay, so you can technically see how high and low it is going. What's the highest and the lowest?
-4.
It's -4 to 4. And that is including -4 and 4. What's the amplitude?
4.
The amplitude is 4. And what's the period?
1/3. How do you find period? Just 3, right?
3 is the b value. That's not the period.
2 pi.
What is it?
2 pi over 3.
2 pi over 3.
So you got it right.
So it's 2 pi over the b value, which is 3.
Okay.
So what if I specifically asked you to draw that on the screen, but only show me 2 cycles, 2 periods? How wide would your window have to be to show 2 periods?
Maybe 4 pi.
4 pi over 3 would have to be the width of your screen to show 2 cycles.
Alright, why does that one look so much different than the one that we grabbed? That. Well, why does that look different from the segment? Oh, because it's a completely different thing. Never mind. Okay.
So if I wanted you to show me 2 cycles on the screen, that means I want to see something that looks kind of like this. 1, 2. Stop. That's 2 cycles. What could I use for an x min and an x max that would show me 2 cycles? It just has to be 4 pi over 3 units wide. There's a lot of ways to do that. Yep.
2 pi over 3 and -2 pi over 3.
Yeah, you could do -2 pi over 3 to +2 pi over 3. It didn't say you couldn't use a negative. 2 pi over 3. And if you type that in, you should see exactly 2 cycles. Perfect. What else could you have done besides -2 pi over 3 to +2 pi over 3? Yep.
Positive 4 pi over 3, or 0 to positive 4 pi over 3.
Yeah, you could have done 0 to 4 pi over 3, and that just would have showed you this cycle, and then the next one. So sometimes they ask us to manipulate the window so we only see a certain number of cycles. Usually you don't need to see this many. Zoom 7 is just kind of a starting point, but we may have to change the window from there. Okay, is the amplitude always the same as the high value in the range?
No.
No, not if you shift it up. You could have a graph that's been shifted up like that, where the high value is 3, but the amplitude is only 1, okay, or half, or whatever. Okay, so the amplitude doesn't always match the maximum value in the graph. In this case, it did. All right, let's try this. Find a complete graph of 3 sine x minus 1. So 3 sine x minus 1. All right, and zoom 7, gives you a good enough picture of it. Oops. All right, so let's start with domain. It's always all. Sine and cosine is all real numbers all the time. So let's just write. All right, how about my range?
-3.
Including or not including? Yep, including it. Let's see, we need the amplitude. What's my amplitude? 3, absolute value of the number in front. And what about my period?
That would be -2. Sorry, -2 pi. I think.
Well, period is a length, so the length can't ever be negative.
Yeah,
Isn't it
2
just
pi.
2 pi?
It's just 2 pi over 1 because there's just a 1 in front of the x. So what would change if I made that a negative? Nothing. Putting a negative in front would not change the domain, the range, the amplitude, or the period at all. It would flip it, but all that would mean is now it looks more like this. Doesn't change any of these facts. Okay. Any questions on that one? All right, so we kind of already looked at this a little bit, but I mentioned to you that if you see a graph, you don't always know how that graph was created because there's so many ways to draw exactly the same picture. We learned that sine and cosine are almost the same thing, except they're shifted. Does anybody remember the amount of the shift?
90 degrees.
90 degrees. And you can think of it either way. If you take the sine function and you shift it to the left 90 degrees, it turns into the cosine. Or take the cosine and shift it right 90 degrees, and it turns into the sine. And the reason this is an identity is because it's not just true for certain angles, but it's true for every single angle. If you take an angle and you add pi over 2 to it, and then take the sine, it's exactly the same as if you had just taken the cosine. For every number you can imagine for x. And that ties in a little bit with what we did on Monday, talking about identities, formulas with trig functions that are always true. Any questions on those two formulas? We are going to come back and use these.
Are the trig functions going to be on the test, or is it all over the graphic? Like a little bit like Monday, or no?
The Monday stuff? Yes, the Monday stuff will be on the test.
Okay, because I think we have to.
We did 6.2 part 2 on Monday. Yep, that'll be on there. I'll put a list on the video. Okay, so when we talk about solving trig equations, a lot of these we're going to do with algebra eventually. But I'm going to show you how you can do this on a calculator. Maybe I'll show you something with algebra quickly, but we're gonna focus on the calculator. Now, one thing I want to think about when we do it, I want to think about it graphically. And we've done this kind of thing before. Okay, we've got something on the left, we've got something on the right. When we graph here, what would we be looking for? If we wanted to find where the sine of x equals 0.4. Yeah?
Intersection.
We'd be looking for an intersection. Now, sine of x is a wave. What does 0.4 look like if we graph that? What kind of line? A horizontal line. So think of the graph of sine. It's a wave. and then you have a horizontal line. As long as that horizontal line is between 1 and -1, how many times is it going to cross the wave? It's going to cross it infinitely many times. So what we have to do is look at the directions and see, do they tell us to just write the answers in a certain section? Like maybe they only want the answers in that screen. Okay, so let's go back. Do they restrict where my x answers should be?
Yes.
Yes, they do. They only want answers between 0 and 2 pi. That's going to be what we use on our window. And notice how they did it. Greater than or equal to 0, but less than 2 pi. That's because if you think of these in degrees, well, 0 is 0. What's 2 pi in degrees? 360. 0 and 360 are repeats. So if you include 0, you don't want to include 360 because that's the same thing as 0. Okay. So let's graph it. Set our window. So we are not going to use Zoom 7. We're going to set the window by hand and see what we can find. So let's do sine of x and y1. I'm going to do 0.4 and y2. And remember, the x-axis, when you're graphing trig functions, what does the x-axis represent? Like, it represents a certain type of units. Degrees or radians, which means the x-axis is a, if it represents degrees or radians, it really represents yeah? A what? A ray? Well, what are degrees and radians? Angles, right? They measure angles. So this x-axis represents angles. So these two numbers are limits on the lowest and highest angle that I want in the answer. That's what we're really solving for here. We're solving for an angle. So when we start to apply this to trig, we'll have a triangle, and you'll see how we do it more visually when we do triangles. But for now, we're just solving for an angle on a graph, not applying it to a triangle or anything like that. Because these are angles, and I don't see the degree symbol on the 0 or the 2 pi, what does that mean those units are? Radians. So I need to make sure that my calculator is in radians. And it is. So I'm in radians. I typed in my equation. What's my x min going to be? My x max? 2 pi. And the sine function goes how pi and above?
1.
And?
-1.
-1. So will 0.4 be in there?
Yes.
Yeah, 0.4. It's going to hit it. We're -4 to 4 right now. That's fine. You'll be able to see it pretty good. Right. So, how many answers does it look like we have? 2. On the interval from 0 to 2 pi. How many are there really? Infinite. But we're not writing them all yet. We're just writing those 2. So second, calc, intersect. We just hit enter 3 times. It'll give us one of them. All right, so there's 1. 2.73. And what is that? 2.73 what? Radians. So we just solved for an angle. And the other one is second calc intersect. Just move it a little closer. And there's your second one. 0.412. Any question on that? Now, let me show you something. What did we graph? Sine of x equals 0.4?
Yeah.
Okay. Second, sine 0.4. What do you notice?
That's one of the answers.
That's one of the answers. And I found it a lot quicker than graph. I didn't have to type it in y1, y2, do an intersect, hit enter 3 times. So there is a way to do this algebraic with a function that's called inverse sine. We're going to talk more about that later. But did it give me the other answer? No, it didn't. It didn't give me that other one. So to get that other one, I would have to do pi minus the answer that I just got. And did that give me the other one?
Yeah.
Yeah. So how did I know to do pi minus it? Well, we're going to learn more about it, but the fact that this number was a positive, that number was a positive number, that told me a lot. And it told me the fact that I needed to use pi and the fact that I was using sine. So we're going to learn some tricks. Sometimes you subtract it from pi, sometimes you add it to pi. It depends on what function you're using, and it depends on if this number is positive or negative. But it's a lot faster once you know how to do it algebraically than it is graphically. It's a lot faster. But for now, any questions on the graph? Okay, the graph, it'll work. All right, let's try this one. So solve graphically. That's impossible. Let me fix that.
Wait, what did I say before?
Well, it said find a number that's greater than 2 pi and smaller than 0.
Oh.
That's not going to work. Okay, so what are we going to put in y1 this time?
The 2 cosine 1/2 x.
Yep. So 2 cosine 1/2 x, and then in y2, 1.5. Now, does cosine go up to 1.5?
I don't think so.
So are these two graphs going to cross then?
Well, yeah,
Yes.
because you have a stretch of 2.
Right, you stretched it. So it's not -1 to 1 that the cosine's going to go, it's really -2 to 2. So 1.5 will hit that. If this 2 wasn't here, it would be no solution. Couldn't solve it. Window is the same window we had last time, 0 to 2 pi. So let's just leave that. So you might think we should get 2 answers because that's what we got last time, but this 1/2 stretched it out. Because we've stretched it so much, this answer doesn't come back up and repeat till you're beyond the window they want you to look at. So we only get 1 answer. Second calc, intersect, and the answer is 1.45 radians. So that's the number that you could fill in right there. Multiply it by 2, take the cosine, and then take that number, multiply it by 1/2, then take the cosine, then multiply it by 2, and you should get 1.5. So you're solving for a number that you can plug into a trig function. That's what we solve. Okay, any question on that? And I could do that one algebraically pretty much just as fast as the last one. I would want to put this 2 on the other side first, so that I could at least move something. But we'll talk more about that later. Now, to solve this one algebraically, this could be a little tricky because you have 2 trig functions. So unless there's an identity that you can use or some formula to combine these 2 into 1, that's going to be really hard to solve algebraically. And the other thing that really complicates it is the fact that one of the arguments is a 1/2 x, and the other argument is just a 1x. To solve algebraically, that makes it really bad. That's not good. If this 1/2 wasn't here, then that would be a lot easier. In fact, if that 1/2 wasn't there, I could solve it no problem. But the 1/2 is there. So we're going to look at this one more graphically and see what we can do. All right, so what would I put in y1? 3 cosine 1/2 x. If you want to put in 1/2, you can. It's fine. And then in y2, 2 sine x. And the window, 0 to 2 pi, we're going to leave that just like we've been. Let's think a little bit about the y min and max. Out of both of these graphs, what's the highest we ever need to go? 3. And the lowest? So as long as we go -3 to 3, we're okay. Okay, so there's the left and the right. Okay, so let's look at that carefully. How many answers do we get?
3.
We get 3. Okay, just the way they cross, we end up with 3. So you'd have to do second calc intersect on all 3. I'll do one of them. I'll leave the other 2 for you. You do the one right in the middle. So the first one you get is pi. Usually we don't know what that decimal is. I just recognize that one. That is pi. But a lot of times, like these other 2, they might be decimals we don't recognize. They might be decimals we do. But if it just says to use your calculator, you can always just write the answer as a decimal. So I would take 3.14 for that. If we were solving algebraically, that's when sometimes I expect more exact answers. But graphically, the calculator is always going to give you a decimal. Okay. Any questions on how I got that one or how to get the other 2? All right, so that's solving an equation. This is solving an inequality. Pretty much the exact same thing. You've got to find intersection points, but your answer is not x equals a number. How do our answers look when we do inequalities?
X is greater than or less than something, right?
You could have greater than, less than,
Or
equal to. Yeah, we have intervals,
yeah.
right? Might be like from 0 to 2, and then sometimes we have the union symbol, like 4 to 5, something like that. But before we know, we gotta graph that. Same window. This time, how high and low do I need to go? -2 to 2. So let's just go -3 to 3. Just gonna zoom us in a little bit. Probably don't need to.
Why do you think it should?
Why is it -2 to 2? Because we have a vertical stretch on the left-hand side.
Yeah.
So normally it would be -1 to 1. And that's going to double it, -2 to 2. And if it didn't double it, we would have a problem because -1.3 is not in the range of cosine. But it is in the range of 2 cosine. So we want to know where the graph of cosine is above -1.3. When we describe where the graph of cosine is above that red line, how many sections do we have to describe? We have to describe 2. We need to describe this section. And we need to describe this section. Now, when we describe it, would this be an open circle or a closed circle?
Close. No, open.
Open. We cannot include where they cross because it says it has to be greater. How about on the beginning of interval number 2? That would also be an open circle. Now, how about where interval 1 starts? That's 0. Can we include 0? Yes, we can. The x value that you pick can be greater than or equal to 0. This is where we stop, 2 pi. Can we include 2 pi?
No.
No. So that's the idea of what your interval is going to look like. Closed, open, open, open. Any questions on why those are my symbols? So when I write it, what do I use for a closed circle when I write an interval?
Bracket.
Bracket. And what x value is that at? 0. We know that one. I don't know this value yet, but what kind of symbol is it going to be? Parenthesis. Or, what symbol for that one? Parenthesis. I don't know what it is yet. And what symbol for this one? And that one I do know. That's 2 pi. So this is 1, 2. This is 1. This is 2. How am I going to get my y value? I'm sorry, my second x value. I need to intersect. Okay, second calc intersect. That should be okay. 2.28. All right, and how am I going to get my beginning x value for number 2? We'll do the intersect again. Second calc intersect. Well, that's almost exactly 4. 4.00. Now, what if the inequality was flipped? What if it said, where is the graph below negative 1.3? Where would that happen? Yeah?
That would be between 2.28 and 4.0.
2.28 and 4.00 is where it's below. Yeah.
Why is the 2 pi an open circle again?
Why is which one an open circle?
The 2 pi.
The 2 pi? Because you are not allowed to include the 2 pi in your answer. Like I said, 0 and 2 pi are repeats. So if you include the left edge of your screen, you don't include the right edge when you're doing it like that. Okay, any other questions on that? All right, so what I'll do, I have plenty of time. I'm going to pause it, put the homework up. You've got about 15, 20 minutes or so. I'll unpause it once I put the topics for the test on it. And then if you have any questions, you might have time to ask me a couple questions about the test. Yes, tonight's homework is in the book. So the test tomorrow is 6.2, part 2, and all of 6.2. Okay, let me get you a list of topics.